Welcome back to my channel. My name is Linus Antonio Forejekum. As usual, we're going to look at operational amplifiers today. And so far we have looked at amplifiers and their classifications in lecture 1. We have also looked at the classes of amplifiers, as in the large signal amplifiers, where we looked at the classes A, B, AB, C, and D. We also looked at distortion in terms of amplifiers. Now we're going to look at operational amplifiers, which we looked at as one classification of amplifiers. One may ask, what is an operational amplifier? In simple terms, an operational amplifier is basically a three-dimensional or a three-terminal device consisting of two high impedance inputs. That is the inverting input and then the non-inverting input and one output. Okay, so let's look at a typical operational amplifier symbol, which I would draw for you. So basically, an operational amplifier looks like should look like something like this. Okay, so you have two inputs and then one output, and then you would normally have a supply connected to it, that is the negative Vs, and then the positive Vs. So the inputs, one of them is the inverting and then one is the non-inverting input. So we have the inverting input and then the non-inverting input, and then we have the output. Okay, so basically this is the symbol of an op-amp. So then inverting input is connected to the negative part, and then the positive part is termed as what? The non-inverting input, and then you would normally have the voltage supplies. So the main connections to the op-amp are the inverting input, the non-inverting input, and then the output. And a DC supply, typically positive voltage, which is Vs or positive Vs, and then we have the negative voltage, which is also the negative Vs. Like I said earlier on, the op-amp needs a minimum of 5 connections, as shown in this diagram, as well as the 2 inputs and the 1 output. We have 2 power supply connections, which may be labeled positive Vs and negative Vs, indicating that the IC or the integrated circuit, which is the op-amp, needs both positive and negative supplies. These would often be in the range of plus or minus 5 to plus or minus 15. So the DC supply range is usually plus or minus 5 volts to plus or minus 15 volts. Okay, now plus or minus just means that the positive side is 5 volts and then the negative side is also 5 volts and vice versa. Okay, now the dual supply arrangement, what you normally see here, this supply you see here and the supply you see here, which is the positive and negative supply arrangement, allows for the output voltage to swing both above and below the 0 volts. Okay, and also give an output of 0 when there is no voltage difference between the 2 inputs. Normally there would be an output when there is a voltage difference recorded at the input between the inverting and then the non-inverting inputs. Okay, all right. A growing number of operational amplifiers are available, however, that use a single supply labeled just basically positive volts and a GND or a ground, or zero voltage or 0 volts. Okay, so that is basically what an amplifier or an operational amplifier, which in short terms most people will write, or in some literature you see op amp. Okay, it is a short form of operational amplifiers. Operational amplifiers. Okay, now let's proceed and look at some basic explanation in detail, looking at a more detailed diagram of an operational amplifier. Pardon my sketch. So with this, we can look at our operational amplifier into detail with this diagram here. Okay. So let's take this like that. And then let's have an input, which is this coming in that way and connected to a resistor. And then we have our output, sorry, the other input. Okay, so this and that. And then we have AV and then VD connected to a resistor, and then this goes to the output. So this is R0, and then, sorry, let me do my drawing well. So here we have this. This goes all the way to connect to this. Because of computers lately, drawing has been a thing we don't normally do. Okay, so then we have Ri, which is the input resistance. We have R0, which is the output resistance, and then we have the gain plus the voltage difference times the voltage difference, which we have here as our output. So here we have the positive and then the negative, and then we have V0. Here we have positive Vn, and then we have a negative. Then normally you have it grounded the same way. You have positive Vp, which is the positive voltage, and then here we have ground. Okay, all right. Now in between these two here is what we have as our voltage difference. Now there is going to be a current here which we can term as IN, and then there will be a current here which we can term as IP. Okay, that is the negative current, and then the positive current. And then we also have, so we have the negative current here, and then we have the positive current here, and then we also have our positive voltage and then our negative voltage, and then we have the voltage difference between the two inputs. Okay, so this diagram you see here is what we term as the Thevenin amplifier model. Okay, for standard op amps. Okay, all right. Now, an op amp basically is a differential to a single-ended amplifier. Okay, you remember when we're looking at amplifiers in electronics 1, we just drew it this way, where you had the input and then you have your output. Okay, all right, which is just a single ended, the input and then the output. However, for an operational amplifier, it has what? It is a differential amplifier, in the sense that you have the input being the difference between the positive and then the negative voltage. Okay, it amplifies the voltage difference between the positive and then the voltage, the negative. So normally you would find this equation which represents the voltage difference, which is VD. You would find VD equals to VP minus VN. Okay, that is the difference of on the input port and produces a voltage which is V naught at the output. Okay, so this is the equation for the voltage difference, that is the voltage that goes into the input of the amplifier. Okay, yeah. Yeah, so basically that is what an operational amplifier is. Someone may ask, so what are operational amplifiers used for? They are used for several applications. They are used for applications where you would have to have an inverting output when you have a signal, let's say a positive signal, and you want it to be a negative signal. In an instance where you have several signals that you want to combine, you can use it, and that is termed as summing amplifier. There are several applications which we'll look at as we continue. All right, so this brings us to the short introduction to the end of the short introduction to operational amplifiers. For further videos or lectures, feel free to like our page, Linutech, or subscribe to the page, and then also select the bell so that anytime there is an upload of a new video, you will be notified. Bye.